Hi students, welcome to Aptdemy. The topic that we are going to discuss today is solid and modern materials.
Today we shall discuss some typical problems on vector algebra.
Hello students, welcome to Aptdemy platform for class 11-12 physics. We will consider MCQ problem from laws of motion.
In this slide, we will be considering fraction of any atom as a function of location within the unit cell. So, again let us take the model. So, if it is corner, so for a cube we can see there are 8 such corners, 4 like this, and so this is the 5th, 6th, 7th and this is the 8th, okay. So the corner atoms over here, their contribution, we will say there are 8 of them and their contribution is around 1 by 8. So this is something that we discussed while we were doing the problem, okay, in the previous slide, okay, about NIS. And then if it is in between this edge length, then the contribution over here is 1 by 4, okay. And if it is in the face center, the contribution over here is 1 by 2, okay, that is half. At the edge length we are saying it is 1 by 4, at the corners it is 1 by 8. Now if you are placing the atom anywhere in the cell, within the cell, either in the center or over here, the contribution is going to be 1, okay. So that is what has been described in this picture. And now let us consider an illustration. The structure of metallic solids. Illustration 4 says calculate the number of atoms per unit cell, primitive or SCC, which means simple cubic cell, VCC, which means body centered cell, and FCC, which means face centered cell. So we will say, let us draw the unit cells first. So I am answering part A. So now I will place spheres like this at the corners. And we know the contribution from each such sphere is 1 by 8. So Z is the total contribution from these 8 spheres. So if there are 8 such spheres, we will multiply that with 1 by 8 and the contribution will be 1. So the value of Z, that is the number of cells within this lattice, that is the simple cubic cell, will be, we will say 1. Now let us solve for B, which is body centered lattice or body centered cell. So there are 8 such atoms at the corner and there would be 1 in the middle. So just like before, we will say Z BCC, okay, this is SCC. So here we will say there are 8 such atoms at the corner. So 8 times 1 by 8 plus the 1 that is within the center. So the answer over here is 2. Now we are answering for C, that is for the face centered cubic lattice or cubic cell. So there are atoms at the corner and there are atoms at the center of each face. So top, bottom, right hand side, left hand side, and say this is front and that is behind. Now the contribution from here we are saying it is 1 by 8 and the contribution from the face center we are saying it is 1 by 2. So Z, F, C, C, we will say it is going to be 8 times 1 by 8 plus 6 times 1 by 2, and the total will come out to be as 4. So the answers over here are going to be for A 1, for B it is going to be 2, and for C it is going to be 4. Okay.
The first problem is a vector R is inclined at equal angles to the three axes. If the magnitude of the vector R is 2 root 3 units, then find the value of R. It is given that vector R made equal angles with the axis. So if alpha with the angle it made with the x-axis, y-axis and z-axis, then we can write its direction cosines as L is equal to cos alpha, M is equal to cos alpha and N is equal to also cos alpha, as because the three angles are equal. So from this we can write L equal to M equal to N. Now you know that the properties of direction cosines is L square plus M square plus N square equal to 1. So we are given that L equal to M is equal to N. So therefrom we will get L is equal to plus minus 1 by root 3, and therefore L is equal to M is equal to N is equal to plus minus 1 by root 3. Now what is our vector R? This vector R is equal to mod of vector R. This R is equal to, we can write this as R is equal to this mod of vector R into IL plus JM plus KN. How to find the modulus of a vector? Suppose we are given that R is a vector, say 2i minus 3j plus 4k. How to find the modulus of the vector? Vector mod of vector R, this is the root over of 2 square plus minus 3 whole square plus 4 whole square. In this way you can find the modulus of this vector. So now you are given that the modulus of the vector R is equal to 2 root 3. So put here R equal to 2 root 3 and the values of L, M and N. So therefore we will get this is equal to vector R is equal to plus minus 2 into I plus J plus K.